Okay, this is Pierre Jasmin from RevisionFX, and I'm with Gary Oberbrunner on the other side. Uh, we're here to present OpenFX, which is not a new standard, but what's new is we're joining the ASWF. Next slide. Are you doing next slide? Yeah.
There it is.
Okay, so our agenda today, I'm just going to provide just a bit of context, which including just a bit of history, and then I'm going to pass to Gary, which is going to go around what's inside what's inside the standard, and also in the hope that when it's a video document, someone can use that as an introduction before going to the read the docs and stuff like that. So let's start. Next slide. So OpenFX basically is a mechanism by which by which an host and a plugin, which is a dynamic library, communicates at different level, including handshake at the beginning. So, you can run in this application and what the features are supported and stuff like that. And so just a really short history. So what we're doing right now is since 2009, we've been the OpenFX Association maintaining that standard. And what's new now is we're moving this to be a academy project. It's been about 3 different phases of the API history. So it started in the beginning, around 2002, 2003. Someone that is the legend here, someone called Tom Benoit that was doing a software called OpenFX, approached the foundry to have them support their plugin. And of course, it's the historical usual process. If you have a proprietary API and you have a small user base, how can we support you, right? So, Bruno Nicoletti, which was one of the founders of the foundry, which was doing plugins at that time, built over around 2003 2004, first built a pretty large email list of developers and did a lot of individual one-by-one company meeting to say, so he deserved the title of also of an instigator of this project, creating the sort of corporate political environment to gather people around that. It took about 2 years until we, through this email list process, till we captured what the API should be about, all the content in it. And around, I say around 2006, 2007, we suddenly, like at NAB, had different vendors, different, host application and plugin vendors. So when we formed the association in 2009, I would call that was our sort of our first generation. And at that point, it was mainly compositing system and finishing system, right? Then we had a second generation from there. I would start to say like around 2010, an application like Sony Vegas Pro, it was called then, which then it is really just mainly an editing system suddenly coming in, and also a different type of user, because in the case of Sony was you buy a camera, now you need a computer and an editing system to do something with your movie. And what the nice thing that Sony did also is they built an SDK over OpenFX for their own user base, and through the years, then we had a number of open source project complete application, and the two of note are TotalOFX, which is an IO framework that grab, so it's like a monster version of image IO that grabs the FFmpeg and all that stuff, and support OpenFX as that's all command line. And then Natron is pretty good example of a whole application where all the plugin tools inside are also all their tools are also OpenFX plugins. So that's another tendency that happened, is we started to see more and more host application natively develop their own tools using OpenFX, and some new hosts arrived, like I'd say like itfilm, for example, that became suddenly plugin vendor and host vendor at the same time. And then we arrived to about like close that loop, like would be like Resolve from 12.5, mainly, let's say very stable around version 14 or 15, when they started to add their own editing timeline too. And it's what's not interesting about Resolve is you have the 3 different type of application in one framework, with Fusion, like the compositing effect, the color thing, which is like the historical or finishing apps, and the editing timeline. And it's very good framework to understand that for a plugin developer, within a certain context, there's things you can do and cannot do, something like that. So next slide. Next slide. Sorry.
It's there.
It's not on my screen.
You want this one?
Okay. Yeah. So, so basically, we arrive at a sort of matrix like that, which is there's a ton of applications supporting that. There's a ton of plugin vendor, and what's not clear there's some that are both and stuff like that. Of of this group related, I've noticed Color.io, Autodesk built some OpenFX plugin to document OpenFX, not OpenColor.io 2.0 certain feature. So that's one thing that's interesting for our group, is to there's a little channel of communication with all kinds of problems, representing all these applications that we could be a good interface to. So now I'm gonna pass to Gary to go about what the API or what OpenFX is. Yeah, sorry.
Sure. Yeah, thanks, Pierre. And also definitely thanks to SIGGRAPH and the Academy Software Foundation for hosting and supporting the project. So because we're new to the ASWF, rather than focusing on a status update, I think it's best to introduce you to the basics of OpenFX and what you can do with it. So I'll give you a short overview of how OpenFX works technically, and there'll be plenty of time at the end for any questions you have. You can put them in the chat if you're on Zoom. So yeah, OpenFX, as Pierre said, is a generic C-based plugin architecture. It can actually, it's a layered API. So that base layer is totally generic. It could be used for anything. And then we build the image and video support on top of that. So a plugin at its core is just a shared library with a small set of exported C linkage functions. And we make sure that they're C linkage so that there's never any problem with name mangling or calling conventions. You could even create Rust or Python bindings if you wanted. It's a header-only library. There's no need to link with anything. There are no dependencies. So it's really easy to get going and create a plugin or even create an OFX host. So OpenFX primarily specifies two classes of things. There are suites of function pointers, which are basically just C-based classes, and sets of properties, which are just essentially name value dictionaries. So what does OpenFX let you do? As a plugin, you can define parameters, inputs and outputs, and negotiate features between the host and plugin. Compatibility and extensibility are super important to us, and we'll talk about that a little later. So that feature negotiation step is key to making that work. Then the host creates effect instances and gives them images and parameter values to render, either on the CPU or GPU. And then OpenFX defines a number of different suites that plugins can use to support interaction, memory handling, threading, progress reporting, and a bunch of other things. One difference, if you're used to audio plugins, one big difference between OFX and say VST or AAX is that in OFX, the plugin defines the parameters with their types and min values and max values and so on. But the host manages them and shows the UI and does all the project saving and loading and interpolation. Whereas in an audio plugin system, typically the plugin is responsible for the entire UI. And I think the OFX way gives you much more of a native look and feel within the app. And that's something that we've always tried to strive for, to keep plugins looking completely as if they were just native tools within whatever the host app that they're running in is. So how does the actual bootstrapping process work? The host loads a DLL from some defined location on disk, and it initially finds and calls these two functions, OFX get number of plugins and OFX get plugin, and it calls that n times, which is what allows a single DLL to contain many different plugins. And each time OFX get plugin is called, the plugin returns a struct with some metadata and a function pointer that gets used later on when the host calls the plugin to perform actions. We'll talk a little bit about that. So as I said, the two main things that the standard defines are properties and actions. The properties are essentially name value pairs that are looked up by a simple string name. Both plugins and hosts can have properties, and they're organized into suites. And properties are the primary way that hosts and plugins negotiate features, because on either side, you can query the other side to see if a particular property or particular suite is supported and then behave appropriately. So here's just a simple example. I don't know if you can see it. It's a little small on the slide, but a plugin is using the global property suite that it got from the host to set a string valued property called label, or OFX prop label there. And its value is OFX basic example. So it sets that property into the effects property set on the host, and then the host can use that name to show in its effect selection menu. All right, so actions are where all the action is, of course. Here's a few of the actions. I'm not going to get into the gross details of how, of all the nitty gritty of everything today. We do have pretty comprehensive docs on Read the Docs and in our GitHub. So just a few: load, unload, describe, create instance. The render action, of course, is the whole reason why the API exists. That's the action that the host calls to tell the plugin to render an image given a set of source images and a set of param values. And then it returns that back to the host. And the nice thing is that actions are really just the host calling the plugin's main function with an action name, which is just a string, and a set of argument properties delivered as a struct or as property values. So we try to keep the whole API very simple. There's no fancy C++. There's no, there's nothing fancy about it. And that's one reason why it has lasted so long and why it is so popular. All right, so moving on, OpenFX allows the plugin to define a rich set of parameters. There's 1D, 2D, and 3D floats, integers, booleans, colors, strings, all the things that you would want in a plugin or in any kind of tool. Most of those can be animated depending on what the host allows. And per what I was saying earlier, the host defines the animation curve types that they support, say different kinds of splines or linear, and the host does the interpolation, and the plugin can just get the values at different times. And the reason for that is that it helps the plugins work just like native tools in that host app. There's also support for spatial coordinates that auto-scale as the resolution changes. So for instance, if you have a lens flare and it's centered in the upper left of the image, it'll stay in the upper left as the resolution changes from HD to SD to 4K to whatever. There's also support for angles and times and scales, various other kinds of parameter interfaces. So the core of any video API, of course, is images. So OFX is frame-based. It does have alternate frame access, so you can get frames before and after. So that supports temporal effects like speed changes. The API supports different contexts for effects to be loaded in. So a generator is an effect with no sources, like a texture generator. A normal effect just takes one input and one output. A transition, of course, is two inputs and one output. And the transition contexts are slightly special because the plugin also gets to know where in the transition duration the current time is. And then the fully general context just has n inputs and one output for compositors and things like that. We support GPU and CPU rendering, multi-threaded rendering, pretty much all of the image types and depths that you might want. Now, of course, some of these may or may not be supported by any given host application. So there's always that negotiation between a plugin and a host. There's a rich selection of clip attributes that a plugin can use to render itself correctly. There's full support for region of interest and region of definition as well. One thing that we haven't done yet in the OpenFX standard is added support for explicitly defined color spaces. That's an area that we're working on now, in fact. So currently most plugins and hosts assume that the 8-bit and 16-bit integer formats are Rec 709 or Gamma 2.2, and anything floating point is some kind of scene linear. But that's an area that we're actively thinking about now. There are plenty of suites that allow plugins to interact with various features of the host. One, I'll just pick one, the interaction suite that allows the plugin to draw overlays over the image and get mouse and keyboard events so that it can update parameter values. And there are various other suites as well. So that pretty much covers all of the top level of the API. You can certainly check the docs and the GitHub for more details. But let's talk a little bit about some of the design decisions that we made that have made the project be as successful as it has been and has helped us get to where we are. We decided super early on that it had to be infinitely extensible and 100% back compatible. So the way we approach that is, first of all, by keeping the API layer super basic with just C function pointers and string-based value lookups, right? So you never have to worry about whether your plugin is on this compiler version and the host is on that compiler version. I mean, obviously you do when you're talking about major ABI changes or 64-bit, 32-bit, but the standard shouldn't get in your way for those things. And the second thing we did is we made it suite-based, and each suite is versioned. So when we add new features to the standard, or when a host adds its own private or public suite, it can do that in a way where the plugin can say, hey, do you support this suite, or do you support this property? And then they can negotiate the behavior. So that's allowed us to continue evolving the standard over time and preserving backward compatibility. Hosts and plugins can definitely define their own private or public suites and properties. There are plenty of examples of this out there. Nuke has a 3D camera suite. Vegas, I think, has a stereoscopic suite as well. And just to pick an example of something that we've added recently, the new draw suite is now going to be part of the next release of the standard. That allows plugins to draw overlays on the host's viewer using a device-independent set of calls. Traditionally, that was just OpenGL, but we don't live in an OpenGL world anymore. So we added to the standard a suite of simple device-independent drawing functions that the host can then translate into whatever graphics API is in use, whether it's Vulkan or DirectX or OpenGL or what have you. So yeah, let's see. We realized early on that there was no way we could predict in advance what people would need in the future. And as an open standard, we're always looking to the community for what is it that you need now. So, so if you have ideas or needs, please let us know. Now that we're an ASWF project especially, there's a lot of opportunity for collaboration. So let's see. Also, there is in addition to the actual standard, which is just header files, there is also a C++ wrapper around the API that plugins can use. It's available from our GitHub. It's definitely not required. And I think probably most of the big plugins just write straight to the C API, but it can definitely simplify getting a basic plugin up and running. It's also header only, cross-platform, nothing to link with. And of course, if you use that, the actual plugin API is still fully C-based, so you never incur any compatibility issues. One thing we don't have yet is a C++ layer for host apps to enable a new host app to more easily support OpenFX. We would love to collaborate with anyone who's interested in doing that. So let's see. What's next from OpenFX? The draw suite that we discussed, that will be in the next release. It's already available now on the main branch. And I should take a step back here and say that we do have defined releases, but because the whole API is based around this sort of versionless suite concept, you don't need to say, well, we definitely support up to version 1.4 or version 1.3 or whatever. You as a plugin vendor can simply support the draw suite, and then any host that supports it, it'll automatically start working. Some other things that we have in discussion right now are full color space management. Probably we'll want to use OpenColor.io for that, but that's a topic for discussion. We do have CUDA texture exchange for fast GPU rendering. There are proposals for OpenCL, Vulkan, and Metal texture exchange as well. Would love to get those done. We've had a proposal for a new timeline suite as well, maybe based on OpenTimeline.io, so that a plugin can know where it is in the global time, not just locally, where frame 0 is the beginning of the effect. And we're working also on improving the handling of some multi-resolution scenarios. But the main reason we're here today is to find out what the community would like to see. You know, that's our whole reason for joining the ASWF, is that we want to go beyond where the standard is today. We want to get more community involvement, both on the commercial side, yes, but also much more in the open source side. So we're actively soliciting community volunteers and contributions. And I'll talk about how to do that at the end. Some other things that we would love to see from the community are a compliance test suite for hosts and plugins. Right now, today, if you are a plugin author, then you have to test against a bunch of hosts. And if you're a host author, then you have to test against a bunch of plugins. And it would be great if we had essentially some test plugins, test hosts that would exercise a bunch of the features. And similarly, more examples showing different features would always be useful. Documentation improvements. We would love to modernize the C++ layer. And as I said before, it would be great if there was a host layer that would make it super easy to onboard a new host app. We've been working over the last year or so on a host and plugin feature support matrix. So which suites, which functions, which features of the API does a given host or plugin support. And we would love to get more information into that. And then, of course, as I said, we would love to get more folks from the broader open source community involved. So how can you contribute? OpenFX is an open standard, and it has been since the mid-2000s. Anyone can contribute ideas through our GitHub. Everything except for the standard itself, in other words, the header files, is managed through a very standard open source pull request based product. So that's the docs, the examples, any fixes, and the C++ layer. Those are all just basically submit a PR, we will review it, and merge it on in. The standard itself, because it is a standard rather than just a library that we deliver, is managed more as a standard definition process by the technical steering committee. But it's still all done in the open on GitHub. It just means that there's more phases to that. There's a proposal, discussion, implementation, and acceptance. And the interesting thing about that process is because we're a plugin standard, in order to be approved, a new suite or a new feature should have one host and one plugin implementation, ideally from a different company, so that we can all see that it's working. And that process has worked well, but we're super excited to get out there more and get more contributions. Also, I didn't put on this slide, but now that we're part of the ASWF, we'll be having regular TSC meetings that will be announced on the ASWF Slack and on our new mailing list. So those are totally open. You're welcome to come to those and discuss things with us. So that about wraps it up for us. Here are some links for how to learn more and how to contribute. Our GitHub, we probably will be transitioning that to the ASWF organization, but thanks to the magic of GitHub, it'll leave breadcrumbs behind so you don't have to change your existing clones. Our docs are live on Read the Docs. We have a brand new mailing list, again, thanks to ASWF, and a Slack channel that's just getting going. And we've had an unofficial Discord channel for a while. So that's it for the organized part. We'll turn it over for questions, but before I do, I just want to thank Pierre and all of the other OpenFX Association directors who have stuck with us for all these years: John Paul Smith, Dennis Adams, Peter Hoosma, Phil Barrett, and plenty of other folks. So yeah, let's take some questions. I see that there are some in Slack.
I've got one though first, Gary,
yeah,
here in the room.
Sure, let's do with the room first.
Can me and Gary talk at the same time, or do you hear me?
I can hear you, Pierre.
Okay, just checking. I just want to say just one note before, at least for the VFX reference platform, we're a no cost new project, because by definition, we're about not breaking anything.
Yeah, because we're header only, so we sort of automatically work on the latest version of Red Hat.
We have people that run 10 years old OS with new plugins, and it still works, right? So.
Yep. So yeah, questions from the room.
Hi, so given the VFX reference platform, so recently as we are upgrading to C++ 17 and our software, host software, I ran into the problem that some of the C++ layer of OFX host support was not C++ 17 compatible. So using, I think, throws keyword, well, no except instead.
Yeah, are you talking about the examples C++ wrapper?
Well, it's
Yes.
in a OFX host support library.
Yeah.
That's possible.
Which has a C++ layer.
That we agree with that. That needs maintenance. So in our definition, we have the core API, which is the C API, and then we have in the support example a C++ wrapper that needs updated. That's correct.
Right. So the question is that given that I had to make some changes to this library to get it working, when, is it going to be released anytime soon, or do you have any roadmap for that? So for contributions,
please submit a pull request and we'll approve it very quickly and get it right into the main line.
Okay,
because we're not tied to a version specific release date, right? So
yep. Yeah, that's the kind of contribution that we would love to have. So yeah, just submit a PR and we'll review it. And yeah, your point is good, actually. And I didn't really talk enough about that. If you use the C API, you're pretty much guaranteed compatibility, except for, of course, the stupid glibc stuff that happened a few years ago. But if you depend on if your plugin or your host depends on a particular version of the C++ runtime, then you can run into troubles.
On Windows, it's not an issue for us because we're not.
For example, it's all dependent on the OS.
You can add two different runtime and stuff like that. I know this is possible. I haven't encountered it yet, right? Basically.
Yeah.
In Linux or whatever. Yeah.
So more questions from the room?
Hello. I have a question. Not sure how relevant it is, but I've used OpenFX on Doom Harmony with success. It's the only concern I have is because it only looks for the plugins in a certain location. It's a little bit harder to manage because I would prefer to have it in kind of a common location for deployment.
Hmm.
Otherwise, I have to install on every artist's computer, and it's harder to manage. So, is there a way to tell OpenFX to find a specific directory where it
No,
can
no,
look
no.
for the?
There-
If the host is compliant, then yes, there is an environment variable that you can
Yes,
set.
there's an environment variable that there's three places. There's a default location. The plugin, the host application can do whatever it wants within its own environment, and then there's environment variable that the host is supposed to look up and look there instead of the default folder.
Yep.
Okay, good.
Right. And if a particular host isn't doing that correctly, then that should, then that of course is a host bug.
Yeah, report the bug.
Okay. Other questions from the room?
I think you can pop over to Zoom. or
Okay.
Slack.
Yeah, cool. So I see one from Joshua Miner. Says, is there a mechanism for an OpenFX plugin to query metadata from the input media or to provide output metadata back to the host application? Pierre, do you
That's
want to
our-
take that one?
Yeah, well, that's also on our list of to do. We initially had a long discussion and never implemented, just for passing just matrix like 3x3 transform and stuff like that. But that's really so, and that's something I'm very interested in, right?
Yeah.
Yeah. So.
And
the-
Open Timeline now may help us with that, right?
Yeah, there's a challenge here in terms of extending what's already there, like the project properties or whatever, right? This world, like where we consider we're a frame on a clip, and there's something called a parent of us, that could be a comp or whatever you want to call it. We call it a project, right? And there's the problem of fetching data there's data that can be parameterized, right? Because in a plugin, so the transport in general between host between parameter plugin and host metadata is very weak in general, right?
So what I would say is come to our next TSC meeting and let's discuss it.
Yeah. So that's one thing because I would like to do with OpenFX is break up little nugget like that problem in interface with different group that have the similar problem, right? Or something like that. Because a lot of, we tend to have, historically, a lot of good discussion about those problems, but little outcome because it's a complex industry problem, right? Or something like that, yeah.
Yep. Okay. I think that was the only question that I saw in the Zoom. So if there are any others, now's a good time. Otherwise, we can wrap up.
Yep, I think we're good to wrap up.
Okay. All you West Coast folks can go have lunch. Thank you very much.
All right. Thank you again to Pierre and Gary. We have an hour break for lunch.